Hello everyone. We are going to continue on chapter 2, solving equations and inequations. Here we are going to look at section 2.6, which is solving inequalities algebraically and graphically. The topics we are going to cover in this session is using properties of inequalities to solve the linear inequalities. We will solve polynomial inequalities and inequalities which involve absolute values. So let's look at some of the properties of inequalities. Now, the inequality symbols which we are all familiar with are less than, it's a strictly less than equal to, greater than, and greater than equal to. Now, we were using these inequalities to compare two numbers or denote subsets of real numbers. For example, x is less than equal to -5. But here, we are going to study inequalities which contain more involved statements, such as 2x minus 3 less than equal to x minus 1. Or we can have -4 less than equal to x minus 3 less than equal to 1. So continuing on these properties, what this basically means is when I want to solve an inequality is I would like to solve for x. And when you would like to solve for x, what basically this is saying is that get the x on one side of the inequality and solve for that. So for example, we would like to know, so let's look at this example, 2x minus 3 less than equal to x minus 1. Now, we know that 2 is a solution, so let's prove it, that is 2 really a solution to this? So what basically it means is you take 2, plug it wherever you see an x. So let's plug it this over here. So it's 2 times 2 minus 3 less than equal to 2 minus 1. So what you get is 4 minus 3 less than equal to 1. 1 is less than equal to 1. Yes, this is totally right. So 2 is the solution. So let's look at one of the values of a real number which is not a solution. So let's look at number 5. Let's plug it in the same equation. So it's 2 times 5 minus 3 less than equal to 5 minus 1. We have 10 minus 3 less than equal to 4. And we're saying, hey, 7 is less than equal to 4. That does not make sense. This is not possible. So clearly 5 is not a solution for us. So when we talk about a solution of an inequality, what we are basically saying is, what are the set of all real numbers which satisfy that inequality? So when we combine all this, all the real numbers which satisfy it, we say that this is the solution set of the inequality. And we can also represent that graphically. The set of all those points which represent the solution set is also the graph of the inequality. There are going to be many kinds of inequalities. We are going to look at some of these examples in a few minutes. Okay, so let's take, before we let's go back and look at this example. -4 less than equal to x minus 3 and less than equal to 1. And see what is the solution set for this one. Okay. So we have -4 less than equal to x minus 3 and less than equal to 1. So when you want to find, that means you want to get x alone. So what are we going to do is add 3 to the whole equation because we want to get x on its own. So what do we get? -4 plus 3 minus 1 less than equal to x less than equal to 4. So what it simply means is all the values between -1 and 4 And we're going to include this little equal sign means you're going to include this in your solution set. So this is the notation in the most simplest form, but so there are many ways we can write down the solution set. So we can write down in the interval notation. So when we want to write down the solution set in the interval notation, this would be -1 and 4. Because we're taking into account the equal sign basically means a square bracket. Or if we want to write it show it in terms of graphs, so we can do it in terms of graphs. Let's look at how the graph would look like. Graphically, we will just simply draw a real number line and eyeball -1 and 4. Now, because -1 and 4 is included, so you basically use the square, the brackets to show that that is included, and then you just simply shade, just draw some lines. That this is the solution set for the problem we just looked around. Okay, so that's a graphical representation, and this is the interval notation. And it means all real numbers between -1 and 4 will satisfy this inequality. Okay, let's look at some more properties. Now these properties are, if you have, say, 4 real numbers A, B, C, D, the transitive property means if A is less than B and B is less than C, then A is less than C. Just let's plug in some numbers. We know that 3 is less than 5, and we know that 5 is less than 7. So clearly 3 is less than 7. That's what this transitive property says. Now, addition of inequalities. It says if 3 is less than 5 and C is less than D. So let's look at what this says. So suppose we have 3 is less than 5, and we also know that, say, 9 is less than 12. So when you add these two, so 9 less than 12. So basically this means 9 and 3. Let's pick up another number, say 16, to show some differences here. So 9 plus 3 is what? 12 is less than 21. That's what it simply means. That's called the addition of inequalities. Addition of a constant. If I have 3 less than 5, let's go back to the same old things here. So we say, hey, 3 is less than 5. So if I add a constant on both the sides of this, so if I add, say, plus, say, 2, and at plus 2, then clearly, so 3 plus 2 is what? 5 is less than 5 plus 2, 7. So this also makes sense. That's addition of a constant. Now, when you multiply by a constant, that's a very different story. You've got to be very, very careful over here. So I'm going to get us more space to show this multiplication by a constant. Okay, let's look at this part. Multiplication by a constant. Okay, let's go to our classic idea that 3 is less than 5. So I'm just basically doing this, guys. Okay, now multiplication by a constant. 3 is less than 5. Now if I multiply both sides by a positive number. So if I'm going to multiply, say, this by, say, a 4, and you multiply this by a 4. So if 3 is less than 5, you multiply a positive constant, you get 12 is less than 20. There's no problem, it works. But on the other hand, if I'm going to multiply this inequality by a negative number, look what happens. Say 3 less than 5. Now we're going to multiply by a negative number on both the sides. Very simple negative number, minus 1. What do you get? Minus 3 and minus 5. Now clearly minus 3 is not less than minus 5. Rather it is strictly greater than minus 5. Very important this part, guys, is a very, very important concept, that if you are multiplying by a negative number, then you change the inequality. If it is positive, that becomes negative, less than becomes greater than becomes less than. So this is a very, very important fact, guys. Okay, now all these properties we are looking at less than symbol is also going to be true for greater than or less than equal to. Okay, that's what it simply means. A is less than equal to B, that means A, when you add a constant both the sides, A plus B is less than equal to B plus C. So now what we're going to do is going to do a lot of examples. Okay, let's start with a very simple one, this was the beginning example I had taken. And we are going to now do, so a little bit more of that. Now we said 2x minus 3 is less than equal to x minus 1. The first thing we're going to do is get the x's on one side of the inequality and the constants on one side. So we get 2x minus x less than equal to minus 1, and you take the positive 3 here. So you get x less than equal to 2. So this simply is the set of all real numbers less than equal to 2. We didn't show it in the notation form. Oh, this should be, guys, 2. Is minus infinity, comma, 2 with the greater than the square bracket. Remember one thing, when you're having any brackets next to infinity or negative infinity, we are always going to be having a parenthesis. Very, very important. Now, how would you do the graph? Very simple, just draw a horizontal line, eyeball the number 2. Now these are all values less than equal to, so that means everything comes over here. But because of this equal sign, we make sure you show that with the square bracket facing these little lines. Okay, now let's go ahead and do a problem where our example is having an x in the middle. So, and also we are having a combination of a less than equal to and a strictly less than symbol. So here we are having negative 3 less than equal to 8x minus 5 strictly less than 2. Remember, we want to find for x, that means x should be on its own. So the first thing we're going to do is add a 5 on both sides. The whole inequation, we add a 5. So that means this is minus 3 plus 5, 2, less than equal to 8x, strictly less than a 7. Remember, we have to solve for x. That means x should have coefficient 1. Now we divide by 2 throughout, 8 throughout. So you have 2 8s less than equal to x, strictly less than 7 8s. That's a common 2 over here. We get 1/4 less than equal to x, strictly less than 7 8. So in the notation form, the solution set is given by 1/4, and it has a square brackets next to it, comma 7 8, which has a parenthesis next to it. How will we draw the solution set? Clearly, 1/4 is definitely less than 7 8. So eyeball 1/4 and eyeball 7 8. Now for 7 8, you will have a parenthesis which is opening on the left hand side, and on the 1/4 you will have a square bracket which is opening on the right hand side, and everything in between is your solution set. We are now going to be looking at absolute value problems. Now absolute value problems, guys, has a very fundamental formula we have to keep in mind. Here, if you have, so if x is a variable and a is any positive real number, so let's say x be a variable or an algebraic expression and a is any positive real number. So we would like to know what are the solution sets for x less than a, an absolute value of x strictly less than a. If you have this scenario strictly less than a, then you simply write this as the other way of solving this problem. In other words, to get rid of this absolute value, we put a minus a on the left-hand side, strictly less than x, strictly less than a. But if you're looking at absolute value of x strictly greater than a, then there are two parts to it, that x is strictly less than minus a, or x is strictly greater than a. Now these are very, very important for us when we solve problems. Now this strictly less than symbol can be replaced by a less than equal to or a greater than equal to symbols. So we start with a very simple example. Absolute value of 3x less than equal to 4. Now remember the rules. If you have an absolute value of x or any expression less than equal to a, the way we write this one as, it is if and only if minus a less than equal to x, whatever the expression is inside, less than equal to the constant a. So here my a is a 4, and this x is now being replaced by an expression 3x. So when we want to get rid of this little absolute value, we are going to write minus 4 on the left-hand side, then a less than equal to symbol. This whole expression 3x, guys, pops here. And then less than equal to 4. And then you normally solve as for your x. Now here we only have a 3 in the front, so we just divide this whole inequation by 3. What do we get? Minus 4/3 less than equal to x less than equal to 4/3. So what's the solution set? It's this notation. Just take the endpoints of this interval, plug it over here. But keep in mind, because it's in a less than equal to symbol, they are being replaced by the square brackets. So if I want to make the graphical set, just eyeball and write minus 4/3, 4/3. Because these are less than equal to symbols, just you go ahead and put your square brackets and then just go, because it is in between these two terms, and that's where is your solution set. Now, we're going to look at another problem where we have a strictly greater than symbol. So this is absolute value of x plus 6 greater than, strictly greater than 7. Now remember, once again, this was the formula. If your absolute value of x is strictly greater than a, if and only if x is strictly greater than a, or x is strictly less than minus a. So this means, that means x plus 6, because that's what our expression now x is being replaced by, is strictly greater than 7, that's my a, guys, or x plus 6 is strictly less than minus 7. Now solving over here, you want to have a negative 6 on both the sides. You will get x is strictly greater than 1. When you do x plus 6 strictly less than minus 7, you have a minus 6 on both the sides. You get x is strictly less than minus 13. So we have two parts to the solution set. When x is strictly less than minus 13, that means you are having minus infinity to minus 13 in the sec notation form, and because you're not having an equal sign, you're just simply going to have parentheses. And then there's another part, x is strictly greater than 1. That means you start from 1, that goes till infinity, and we have our parentheses. Now both of them are solutions, so this little or is being represented, so you can think this little union as or. So how do we graph it now? Draw the number line, eyeball minus 13, eyeball 1. Now 1 and above, and just draw your normal parentheses facing on the left and just shade it. Now for minus 13, you're going to draw x is less than, remember, strictly less than. You have your parentheses and then you draw your shade, your part on the left hand side here. Okay, one more example and then we are done with this section. It's a little bit more tougher than the previous ones. Okay, here we have a problem where here's 10 multiplied to 1 minus x strictly less than 20. Before we go ahead and apply this, we have to be very careful, because what is our formula saying? Our formula says absolute value of x strictly greater than a. That means in front of the absolute value, you have to have the coefficient 1, which is not present over here. Okay, so that's the first thing we have to do. We have to get the 10 out of here. That's how do we do it? We divide this whole inequation, and it's a positive number. So it's not going to affect the inequality by 10. What do we get? 1 minus x absolute value strictly greater than 2. Now we can go ahead and apply this formula which we have here. And what is the formula saying? That x, if absolute value of x is strictly greater than a, if and only if x is strictly greater than a, or x is strictly less than minus a. So what does it mean in terms of this inequation? 1 minus x is strictly greater than 2, or 1 minus x strictly less than minus 2. Then we solve. Let's start with this one. 1 minus x strictly greater than 2. Then you add a minus 1 on both the sides here. What do we get? Minus x strictly greater than 1. Now remember, to have a solution, the coefficient of x should be 1. Now in order to get rid of this minus, what are we going to do? We are going to multiply this whole equation by minus 1. Now when we multiply by minus 1, I forgot that this is minus 1, guys. When you multiply by minus 1, then this inequation becomes strictly less than. So it says x strictly less than minus 1. X strictly less than minus 1. So the solution set here also is this minus 1. Okay, now let's look at this next one. 1 minus x strictly less than minus 2. Once again, you will add a minus 1 on both sides of this inequation. Minus 1, minus 1. What are we getting? Minus x strictly less than minus 3. Now we have to get rid of this minus 1. What are we going to do, guys? We're going to multiply this whole equation once again by minus 1. Now when we are doing it by minus 1, notice what happens. This greater than x, this a greater than, is going to become, I forgot. So this is strictly greater than. So x is strictly greater than positive 3. Well, this was right. That's good. So when you write down in the interval notation, 3 strictly greater than and infinity, and then you have your parentheses. So let's do the graphical representation. Minus infinity to minus 1, eyeball minus 1, and then just basically shade. And remember, x is strictly less than minus 1. That's what we are showing over here. Whereas when x is strictly greater than 3, eyeball the number 3, x is strictly greater than. That means we shade this part. And this one is this. Thank you, guys.